All right, we are today doing our fifth lesson of the Solving Quadratics unit. The topic is solve vertex form by taking square roots. Take a moment, pause the video, and get that down. Okay, once you're done, go ahead and find a new page, and we're going to set it up like this. Essential question, how do I solve quadratic equations in vertex form by taking the square root? So again, go ahead and pause that video, get that down, and then press play when you're ready. So just to review, what we were doing last class was something like this. X squared plus 3 equals 7. And this is in standard form. And we know that it's in standard form because there are no parentheses, there's an x squared, so that's standard form. The x term is missing, but that is standard form. And when we're dealing with standard form, we use order of operations if that b term is missing. And so what we did last class was we subtracted 3 from both sides to get x squared by itself. And I'd actually like you guys to finish this up. I want you to tell me what x is equal to, remembering that there are going to be two answers here. Okay, so hopefully you figured out 7 minus 3 is 4. Then we have to take the square root on both sides, square root the left, square root the right. Whenever you take the square root on both sides, you need this plus or minus symbol. So x equals plus or minus the square root of 4 is 2. So this means x equals 2. And x equals negative 2. When we're solving quadratics, not every time, but often we do get two solutions. And that's because of the shape of parabolas. A lot of times a horizontal line crossing them crosses at 2 points. Okay, let's do example 2. So this was what we did last class. Today, we're going to be talking about something really similar, but not the same. This is in vertex form. And that's because we have one set of parentheses and a squared. So that means vertex form. This is similar but different. If we think back to our order of operations, which I'm going to write over here on the side, we have grouping, exponents and roots, multiplication and division, addition and subtraction. So when we solve, we go from the bottom to the top, but you can see that what's inside the parentheses when we're solving, that is actually going to happen last because grouping is the first thing we do when we're doing order of operations, and that means when we solve and we're undoing everything, it's going to be the last thing we do. And so this set is going to have to wait. So if we just think through this, like we've got some group to the second power is 4, and I'm hoping you can realize that that group, whatever's inside, could be 2, because 2 squared is 4, or it could be negative 2, because negative 2 squared is 4. And so we just need a way to write that out. And what we're going to do is kind of work our way. There is addition and subtraction here, but because it's in the grouping symbol, we have to do that last. There's no multiplication or division here, but the first thing we have to deal with is that exponent. And the way we get rid of a squared is with the square root. And so for this problem, our first step is going to be square rooting both sides. The square root and the squared cancel. So if we think about what's still here, if the square root is gone and the squared is gone, all we have is x plus 3. And we really don't even need the parentheses because nothing else is going on. Equal sign. Whenever you take the square root of both sides, you have to put your plus or minus on the side that doesn't contain x. You may want to write that down. I'll say it again. Whenever you take the square root of both sides, the very next step, you have to put the plus or minus symbol on the side that does not include x. So the square root of 4 is 2. And this is kind of what we thought, right? X plus 3 could be 2 or could be negative 2, because that's what's inside this group. So now we do this thing similar to what we did last class. We're going to split this off into two equations. One equation is going to use the positive 2, and the other equation is going to use the negative 2, because this, since there are two different numbers here, it's actually two different equations. So that means x plus 3 could equal 2, or x plus 3 could equal negative 2. And now we have two baby equations to solve. So to solve this guy here, we're going to subtract 3 from both sides. 2 minus 3 is negative 1. I'd like you to finish this equation on your own. So if we subtract 3 from both sides here, negative 2 minus 3, when you type it into your calculator, make sure you don't put two negatives in there. It's just negative 2 minus 3 will give you negative 5. So there are two answers here, but this time they are different, right? Last class, we were always getting plus or minus something. When we're dealing with vertex form, we often get two different numbers as our answer. And this makes sense because negative 1 plus 3 is 2. 2 squared is 4. Negative 5 plus 3 is negative 2, and negative 2 squared is 4. We're just going to do two more examples. 2 times the quantity x minus 1 squared equals 18. So here, vertex form. With vertex form, we can use inverse operations to solve. So I'm going to come back over here to my order of operations and start at the bottom. There is addition and subtraction, but it's inside the parentheses, and so that has to happen last. So moving up, is there multiplication and division here? Yeah, that's multiplication right there, that times 2. So we're going to deal with that multiplication first. Now, a lot of you are probably wanting to use the distributive property here. We learned that when we were doing linear equations, it does not work with quadratic equations because of this squared. If you distribute the 2, you're forgetting that x minus 1 is multiplied by x minus 1 here. And if we try to multiply this by 2, we're leaving stuff out. So you cannot use the distributive property. In fact, I'm going to say don't use distributive property, which is the double rainbow. Okay, that's a no-no. So instead we use inverse operations. Multiplication and division, the way we get rid of a times 2 is with dividing by 2. So we'll divide by 2 on both sides. These 2's are going to cancel. And whatever's left drops down. So I've got x minus 1 quantity squared drops down. 18 divided by 2, go ahead and figure out what that equals. Okay. And now we have to deal with whatever comes next. So there was no addition or subtraction. There was multiplication and division. We dealt with it. Now we deal with exponents and roots. And so our exponent is a 2. We divide on the left. We divide on the right. Every time, I meant square root. Every time you take the square root of both sides, you're going to have to put that plus or minus symbol on the side that doesn't contain x. So let's keep that in our minds. The square root and the squared cancel. All that's left here is x minus 1 equals, this is where I really need that plus or minus sign, and the square root of 9 is 3. So I really have two equations here, not one, because I have one equation that uses 3, and I have one equation that uses negative 3. And so we branch off. X minus 1 could equal 3. X minus 1 could equal negative 3. I'd like you all to finish this up and tell me what the two answers are, and they will be different from one another. So to finish this, we've got adding 1 on both sides, x could equal 4. Add 1 on both sides here, and we get negative 2. So our answers here are 4 and negative 2. One more example. I'm going to turn the page. This will be example, what are we on, 4, I think? Yeah. All right. I'm just going to throw the hardest one at you that I can imagine. We'll see how we do. So negative 3 times x plus 4 quantity squared plus 2 equals negative 13. And I'm going to rewrite the order of operations again so we have it to look at. Okay. When we solve, we're trying to undo everything around x, so we go from the bottom up. So looking at this pretty complicated equation, it is in vertex form because I've got one set of parentheses and a squared. That means I can use inverse operations. So start with the bottom, addition and subtraction. It's in two places. I see a +4, but that's in groups, so that has to be dealt with last. But I also see this +2 that's not in parentheses, and I can go ahead and do that because it's not wrapped up in this squared. So the first thing I want to do is get rid of a +2. So how do we do that? We're going to -2 on both sides. All right, there's a lot going on here. These cancel. -13 minus 2, go ahead and figure out what that equals. Be cautious with those negatives. So it's -15. And then everything else drops down. This entire thing is going to drop down. So -3 times x plus 4 quantity squared, that's gone, equals -15. So I did the addition and subtraction. Now we're going to deal with the multiplication and division. So we're going to start thinking about, is there multiplication and division in here somewhere? And I hope you see that right there, there's invisible multiplication. This is a times -3. So the way we get rid of a times -3 is to divide by -3. So we're going to divide by -3 on both sides of the equal sign. These will cancel. Everything drops. So x plus 4 quantity squared drops. I still need the parentheses because there's still something going on outside of them. And then -15 divided by -3 is 5. Done with that step. Now I look at my exponents and roots. I do see an exponent, and the way to get rid of a squared is with the square root. Square root both sides. I'm going to put a little exclamation point here. Whenever you take the square root of both sides, we're going to need the plus or minus symbol in our next step on the side that does not contain x. So over here, the square root and the squared cancel. I can finally get rid of those parentheses because there's nothing outside of them anymore. Equals plus or minus. And now we have a little issue here because if I take the square root of 5, looking here, it's an irrational number. It's like this super long decimal. I don't want to write that whole thing down, and I'm not quite ready to round my answer yet. Well, I guess we could. Let's go ahead and just round this. The practice I'd like you to use is to round to the nearest hundredth. So that means I want to see two numbers after the decimal. Sometimes you have to round it up, sometimes you leave it alone. In this case, the two numbers after the decimal are a 23. If you look next door, that's a 6. The 6 means we got to bump that 23 up. So the 23 is going to become a 24. So we've got 2.2. Oh, whoops, I did that wrong. Plus or minus 2.24. I forgot to round. Okay. If that number, by the way, after it had been lower than a 5, we would have just kept the 23 as it is. Okay, so the problem is the same, it's just that I have a decimal to work with instead of a whole number, but that's no big thing. We're going to separate it off because we have actually two equations here. Our first equation, x plus 4 equals 2.24, and our second equation, x plus 4 equals negative 2.24. You all go ahead and use your calculator to finish this up. Okay, so there we have it. And you know what I should have done is made little wigglies because these are rounded answers, they're not exact. So I want you to think about how to write a summary for this lesson. When solving equations in vertex form, okay, what did we do? It has something to do with order of operations, and I would like you in your summary to sort of deal with what the plus or minus sign and when we have to use that, because that's really critically important, and that's really the only new thing today. So go ahead and kind of talk about the order of operations and inverse operations and when to use that plus or minus sign, and then write it in your notebook, and I'd also like you to submit it in Edpuzzle. That's it. Good work.